that is implemented for the relief routing decisions. There are three main outlines in this morning, I think. The first one is about the introduction for getting know about the geographic information systems, and also the next one, here we're going to learn about the implementation of the GISO or GIS-based optimization, and especially in the relief routing decisions. But we can also learn about the features that provided by the GIS here. So I will try to show you or make a demo for the implementation in this case, and then the discussions. So I think we may have a discussion in the last sessions after explaining, but if you have any questions, you may ask me anytime you want. So you can raise your hand and you may ask when I'm explaining. So if we talk about optimization techniques, especially in this case, or in the traveling salesman problem, or in the vehicle rating, there are a number of methods that available to be used to solve the problem. But for example, like exact approach, heuristics, and some other methods. But there is one method that can be useful to solve the wide range of the VRP, or the traveling salesman problem. We call it as a geographic information systems approach. So the first thing that we may ask, the question that may arise for when we talk about the geographic information system is, what is the GIS, or geographic information systems? From the definition, we can know here a geographic information system is a computer assisted system for the collection. This is the functions of the GIS: collecting, storaging, and managing, analysis, and also represent the geo reference data to support decision making. So if we talk about the geographic information systems, we can know the functions of the GIS from this definition, starting from collecting, management, and also analysis and representation. And finally, the GIS will be used or will be applied to support the decision making in any area. Almost there are a number of fields or areas that have already implemented the GIS. And if we talk about the GIS again, we can see from the words, the geographic, and also information, and also systems here. We know that geographic, we talk about the geographic is going to be about the spatial, or how to say, the earth, the place on the earth, and also the spatial location. We can call it as a geographic. And then what about the information? So the information is about the need for being informed to make decisions. So based on the spatial locations or spatial data, based on the earth, or under or above the surface of the earth, so we can know the information. We will represent the information, and then we will analyze the information. And this one is going to be integrated as a system. Yeah, we call it as a system, where in the systems we need staff or users, the hardware, procedures, and also the approach, yes, and so many other components that we are going to integrate these components to analyze the information based on the spatial data. So we can see here, for example, if we look at the picture here, so we can use we can look at this one. There are several or a number of layers here, like parcel layers, zoning, topography, wetlands, demographic, land cover imagery, and also the base map. So in the geographic information systems, we're going to use the data or the spatial data, and we make it as a layer. And then the layer, yeah, but for example, the base map imagery and some other layers where we are going to combine, and then we're going to make it as one layers to be later analyzed. So analyzed based on the fields. For example, if we are going to make a decisions about the transportation systems or the relief or routing decisions or about the VRP, yeah, we can analyze here. For example, if in the case of VRP, we may need the road network data, and then the locations of demand point, and then also the depot. Yeah, we can make it as layers, yeah, and then we may analyze, yeah, and then later optimize the routing decisions here. So next, about the areas, yeah, like previously I told before, the GIS has significance, yeah, to be or potential to be applied in a wide range of areas. For example, like civil engineering, transportation, disasters, natural resources, and also tourism planning. So there are a wide range of areas that have already implemented the GIS in their case. So in this area, for example, or especially in the logistics and supply chain, the GIS will be very useful because later I'm going to explain about the use of the GIS in the transportation and also the logistics, and particularly in the routing decisions. So it's very useful because we can also analyze not only about the how to say the constraints, but we can also analyze the spatial data. For example, in the relief routing decisions, there are a number of routes that cannot be passed or cannot be used. So we can make it as a barriers in the GIS. So it's going to be close to the real world. Yeah. Then the software, there are a number of softwares. For example, ArcGIS Pro, ArcMap, QGIS, or Quantum GIS, and so many other software. And here, yeah, in this class later, I will explain the feature of the GIS using the ArcMap. Yeah. And then if you talk about the GIS component, there are five components. The first one is about hardware, of course. Yeah, we have to use the hardware for analyzing the spatial data. Yeah, for using the GIS, for example, our computer devices, and keyboard or something that is useful to enhance the computational time. Yeah, for example, like memory of our device should be enough to how to say to be used later in solving the problems. And then the software, yeah, here, like I told before, there are a number of softwares of GIS. So of course, the software will provide the functions and the tools needed to store, analyze, and also display the geographic information. Yeah, and then about the data, there are two types of geographical data, since we are using the geographic information system. So we are going to use the geographical data. And then there are two types of geographical data. The first one is about the vector data, and then the second one is raster data. Yeah, so I will going to explain this later about the vector data and raster data. And then the next one is methods. So like we saw in this previous slide, there are a wide range of areas that have already implemented the GIS. So based on the areas, there are a number of methods, of course. For example, in the logistics, we are going to use the extensions that may be not used by the other fields. Yeah, I will show the extension later. We call it as the network analysis extension. So this is going to be our tools, or our tools to be exploited when we are using the GIS for for routing decisions. And then the user. Yeah, of course, we need the user to manage the systems and develop the plans for applying the GIS technology. So here, these are the data. So when we want to use the GIS for particularly for solving the routing problems, for sure we're going to need the data. Yeah, vector data and then the raster data. We can see from these pictures. Yeah, vector is going to be like this. Yeah, and then the raster is going to be like this. The raster is going to be like the grid cell or pixel, like here the pixel. Yeah, so the surface, the earth or surface is going to be plot as a raster, as a pixel, and then integrated. For example, like here we have this is going to be like maybe the river here, and then when we use vector data, the data will be presented like this one, in like this picture. But if we use the raster data, it's going to be showed like this one. So this is the difference between the raster. So every raster data is going to be shown as a pixel. Yeah, the picture is going to be shown as the pixel here. And then if we look at the vector data, there are 3 more types of vector data. We call it lines, and then points, and then polygons here. For example, the lines is going to be like the road, road center lines, and then also the rivers, trails, and then also the streets. While the points, for example, like in the routing decisions, is maybe like demand points, depot, warehouse, location of warehouse, schools, and also the polygons. It's going to be like the boundary of the cities, lakes, and also forests. Yeah, this one can be also modeled as the raster data, but remember again, the raster data is going to be like a pixel. Yeah, this is the comparison between the vector and raster data. Yeah, but here in our case, we're going to use the vector data in solving the routing problems. Vector data like lines, the road, and then also the points, or the demand points, polygons. Yeah, we mostly use the vector data in this case, or in the routing decisions. Okay, while some raster data, they may be like some other areas, some other fields, they also use the raster data. And then if what if we just only have the raster data, while in solving the routing problems, we're going to need the vector data. We can how to say convert the raster data to vector data. There are a number of steps in the GIS that allow the user to convert the raster data to or as a vector data. So the raster data may be like the aerial photography. So we may look at the like the drone when we take a photograph using the drone, and then also using, for example, like an airplane to take a photograph on the Earth surface. And then like Google Maps, for example, they use the satellite to take the photos of the surface of for the Earth surface, and then the photo to be converted as a maps in the like Google Maps. They will be used as the raster data. So if we look at the photo, we zoom in. If we zoom in the photo, it's going to be like a pixel like this. This is going to be the raster data. Okay, but here I will explain more about the vector data. Because we're going to mostly we're going to use this vector data to be the input in our routing problems. And this is the example for the maps using the vector data. Look at this. For example, this is the lines of the rivers, and then this are the points, and then also the polygons here. So all of these are in the vector data. While if we look at the raster data, it's going to be like pixels here, mostly taken from the photography results. And then the next one, if we talk about GIS, then the utilization of GIS for routing decisions, we must know about the GIS-based optimization. There is GIS-based optimization, or GISO. Here we call it GISO. So the GISO, or the GIS-based optimizations, will be very useful to solve the routing problems, because they also utilize the heuristics approach, yeah, to solve the problems. In the ArcMap, yeah, the ArcMap software, they use the Dijkstra algorithm for calculating the shortest path, and then after calculating the shortest path, and they will solve the routing problems using the trouble search algorithm. So when we use the GIS-based optimization, we will use the Dijkstra and also the trouble search algorithm. And yeah, the challenges are the complex nature of some strategic problems. Yeah, for example, like in our case here in this class, after the disasters, there's usually like barriers due to the pills, debris of disaster. For example, like a tsunami and also the earthquakes. There are the debris, the piles that will be, or that are going to be the barriers for the relief vehicles to avoid. There are the challenges. To model this, we are going to use the GISO, or the GIS-based optimization. It's going to be easier to map the barriers and then set it as a barrier to be avoided, for example. Yeah, this is going to be useful when you use the GIS-based optimization. So then the question is, what is the GISO? Yeah, if we talked previously about the GIS, the GISO is the integration of the GIS and optimization tool. Yeah, so we integrate the GIS and also the optimization tools, like I previously said. Yeah, the optimization tools will be the heuristics approach, and then integrate it with the GIS. So it's going to be useful for the users to implement, and then to apply, and then to mimic the real systems. And then the GISO is going to be used as the spatial decision support systems. It's going to be useful as the spatial decision support system. So if you have ever heard about the DSS, decision support systems, so if we use the GIS-based optimization, yeah, we're going to say this as a spatial decision support system. So based on the spatial areas in the earth. Yeah. And then when we use the GIS-based optimization, here there is one features or extension in the GIS that is very useful to be used. Yeah, network analysis extension. We call it network analysis extension. I will show you later the network analysis extensions. And here in the network analysis extension, there are some features that we may use, or we may employ. Yeah, for example, like route analysis. Route analysis is going to be the shortest path, and then service area, closest facility, and also origin destination metrics. We can also how to say, we can also make or develop the origin destination metrics here in these features. And for sure, vehicle routing problems, and also the location. Yeah, but here in this course, I think we are going to learn more about vehicle routing problems. Okay. And before explaining the GIS, here I would like to share about the case study or the previous research that I have done. Yeah, actually this research, in this research, I collaborated also with Mr. Wira. So this is the case of the implementation of GISO for relief routing decisions. And then the case is on Mentawai megatrust hazard. So what is Mentawai megatrust? Yeah, Mentawai megatrust is the predicted earthquake that will trigger tsunami, yeah, along the megatrust faults, and then is expected to surge the coastal area of the West Sumatra. So here, this is the Sumatra, West Sumatra. So in this map, you can see that these are the Mentawai Islands, and then the Mentawai megatrust is the issues. Yeah, that is the predicted hazards, the earthquake that will trigger the tsunami with, if I'm not mistaken, yeah, 8 point magnitude, and then they will trigger the tsunami, and it will search the coastal area of the not only West Sumatra actually here or Sumatra, and in this case we are going to focus on the West Sumatra. Yeah. So here are the 7th, if I'm not mistaken, 1, 2, 3, 4, 5, 6, and then 7 areas in the West Sumatra that will be expected to be searched by the tsunami if the earthquake surge. And then in these areas, there is, we can see here the area, this area, Padang City. Yeah, it is becoming the most threatened area, yeah, due to the flat topography and also the high population living in the city. And then for sure, if there are how to say a high number of the population living in this area, for sure they are going to need the help or relief aids for sure. And the challenges is going to be in the last mile distribution. Yeah, the last, what is the last mile distribution? The last mile distribution is the termination stage of the relief aid delivery from the local distribution centers to the people affected by this disaster. Yeah, this is we call the last mile distribution. I mean, this is going to be the last stage or the last phase of the distribution to the final beneficiaries, especially in the relief routing decisions. Yeah, because there are a number of areas or road networks that are going to be barriers, since these areas or these networks will be going will be inundated by the tsunami. So we assume that the vehicles must not use these areas. So here in this case, in this GISO for relief routing decisions, we also consider the expected barriers regarding the how to say the inundated lines or inundated road networks. I mean, we are going to avoid that inundated areas. Yeah, and the challenge we are going to deliver the relief aids or the foods, for example, the foods. Yeah, in this case, we're going to focus on the foods delivery, the relief aids over the 72 hours of the emergency, because after the disaster, uh, 72 hours of after disasters is going to be the crucial periods or critical periods. We call it as the critical period. So it's going to be a challenge for us to deliver the relief aids to the victims or disaster victims as soon as possible within this 70 hours of the emergency. And then, like I said previously, there are going to be damaged path networks that we are going to consider in this case using the GIS approach, and then the scarce resources. For sure, after the disasters, they might be a scarce resource, especially for the vehicles. So we need to know minimum of the vehicles that is going to be or that are going to be used. So this is the issues that raised in this research. And then yeah, we use the GIS based optimization approach, and we are going to employ the network analysis extensions and using this variant of VRP, multi-trip heterogeneous fixed fleet VRP. So we call it multi-trip heterogeneous fixed fleet VRP. Yeah, it means that the vehicle, yeah, may or the vehicle is allowed to conduct the multi-trip delivery. Okay, and then the vehicle has the heterogeneous capacities. Yeah, so here we use it as the type of problems of the VRP. Yeah, and then there are a number of scenarios, the types of vehicles, and then vehicles velocities. Yeah, we can also set in the GIS, we can also set the speeds of the vehicles and then the maximum working time also. And yeah, there are a number of sets that we are allowed to determine in the VRP in the GIS. So I will show you later. Yeah, these are the methods for this research. So the first phase or the first stage is going to be the input. Yeah, about the data source. So we need the nodes or the points or the locations of the demand points, refugee camps, yeah, for sure, and then the depot. So this data is going to be gathered, and then road network and also impassable roads. This is going to be the road barriers that we are going to avoid when delivering the relief aids. So based on the first stage or based on the input, we're going to make it as a layer. So here the nodes or the points and then also the road networks and impassable roads, the data are going to be in the format of vector data. So all of this data will be in vector data. And then this vector data is going to be input as a layer. So nodes, for example, here the location of the nodes, and then the road network here, we use it as a layer, and then impassable roads, and then the layer is going to be combined. Excuse me a moment. Yeah. Here is going to be combined. For example, like there are 3 layers in this case, or in this example, we are going to combine it into 1 layer here. And then the next phase is we use the network analysis extensions. And these extensions, we can set the attribute or the parameters that we are going to use. For example, like the demand requirements, and then also number of vehicles, capacities, and then the loading and also unloading time or service time, yeah, allowable trips, and also the maximum working hours. You can use or determine the attribute or the parameters of the routing decisions here in the network analysis. So it's going to help us to determine the parameters. And then after that, we are going to solve. This is going to be the final output of the models. Yeah, including the decisions about the vehicles or the vehicles assigned, and then also about the route decisions, and then also the loaded items on each vehicles are going to be the decisions or the results of this method. And this is the results of the GIS based optimization. Yeah, in this you can see this one is for the scenarios, the speed scenario 40 km/h, and then in the right side it's going to be 50 km/h. Yeah, we can see in this map this is going to be the route. So in the GIS we can see the how to say the detail route, and then this red lines is going to be the impassable routes or the barriers that we are going to avoid when solving the problems. So this is the power of GIS, I think. Using the barriers here for the relief routing decisions, we can avoid, and then they will decide the decisions for looking for another lines or another that is safe than the red lines here. So this is 40 km/h and then 50 km/h. Actually, there are, if we look at into detail, I mean the results of the assignments, there are going to be difference between the how to say different speed of the vehicles. So here you can see the route assignment for each days, from day 1 to day 3 through over the 72 hours of the post disaster. Then after that we can analyze the utilization. For sure we can analyze the utilization of the vehicles. The first one is about the working time utilization, and then the second one is about the capacity utilization. You can see here for each scenarios, this one is going to be day 1, day 2, and day 3, and then this one's the scenario is going to be like the number of vehicles. Here we can compare number of scenarios here, and based on the working time and also the capacity utilization, we can choose the best scenarios to be applied if this disaster occurs. And then the summary of this research is for sure the proposed model based on the geographic information systems approach by considering or by taking into consideration the impassable road networks. We propose the logistical planning for the relief last mile distribution to face the upcoming future hazard. We call it the Mentawai megatrust hazard. And then for the model characteristics, we have already considered about the impassable road networks or the expected path failures to provide a prompt and appropriate relief delivery for sure. And then the implementation, yeah, this proposed model may assist the relief stakeholder with the proper relief routing decisions by taking into account the substantial issues. For example, like the damaged roads, yeah, then so that this model or the decisions is going to mimic the real world problems. Then yeah, so this is the presentation, and in this in the first session, I think in the next session I will show you about the example of the GIS. So I will make a demonstration about the use of the GIS here. But before that, I think I will if there's any question for me, you may raise your hand before I continue to explain the GIS. Yeah, I continue to explain the detailed demonstration about the use of the GIS based optimization in the routing decisions. So if there's any question, you may raise your hand or you may ask, please. Okay. Okay, so I will continue. Then to discuss about GIS. So here I am using the ArcMap software, ArcMap 10.8 if I'm not mistaken, the version. So if we use or if we look at the software, we're going to get, this is the table of contents. There are a number of menus that we can employ. Yeah, and then this is the network analysis extension that we are going to use here. And this is the data. Yeah, so this is the layer. Okay, so before, or this is the main layout, and then this is the layers, the table of contents. We're going to use this in the GIS, and then also this is going to be the network analysis contents, and then the attribute tables here. We call it as attribute table, and I will firstly explain about the table of contents. So here in the table of contents, we will need layers like previously I said previously. So there are a number of layers, especially in the routing decisions. We're going to need the road network layer. So here, this is actually we call it road here. I will rename. Okay, so if we use the GIS, we can use the these features adding data here. So actually, like in Indonesia, here we have the website for the GIS or the spatial database, including like the road in each areas in Indonesia. So I think in Philippines there must be also the database that we can also use or can be downloaded. So here we don't build, yeah, in this case, actually I don't build this route by myself. So I just download it by the database that provided in the systems here in this case. So based on the database, I can download, and then usually the vector data will be showed as this format, shapefile format. Okay, so the vector data is going to be showed as shapefile format. So when we try to how to say, to download the secondary data, for example, like the road networks data in the from the internet, then we have to look at the type of the data. If we use, say, that the input for the routing decisions, we are going to need the shapefile data. This is the vector data. Here, as I can add the data here, and then we can look at the locations that we have that we save the data. So here I can use, actually these are the same data, the shapefile data, but actually there is a network data set. Here we can based on the shapefile data from the network, we can build a network data set. We call it as network data sets. But here I will not explain the detail about the network data set, since there are not several stages or several things that will be used, yeah, then to build the network data sets. But here I can tell you that if we are going to solve the routing problems, we will need the network data sets. In this case, I have already provided the network data sets, so we are going to use this data in our model, the network data set. Actually, there are for the appearance, actually, we can check here for displaying the layer and the layout. For example, like here, this one is going to be the network data set, and then it's going to be the shapefile data. Actually, they are from the same data, but here in network data set, we have some other input data. For example, like if we want to, how to say, if we want to set the speed of the vehicles, we can set it in the network data set. When building network data set, we can set the elevation sample, and then the speed of the vehicle for go and back, and then some other decisions or parameters, we can set it in the network data sets. Okay, and then after that, this will make it simple to use the, for example, like new route here. So we can use the network analysis extension. Here there are some features: new route, surface areas, closest facility, and also OD metrics, vehicle routing problem, and also location allocation. For example, in the new route is going to be the shortest path. Okay, or we can also use it in the traveling salesman case. For example, here we use the new route and then the network analyst here features for the new route. It's going to be like this. There are going to be stops and then routes. So we have to define the stops here. Yeah, actually we can also input the stops. For example, like right click over here and then locations, find out the I'll say the location, for example, like the demand points and then the starting points. We can input based on the coordinate of the locations. But here I will just only like make an point here, for example, by using this icon. Okay, this one, for example, this one, point one is going to be our first point or starting point, and then point two, point three. Yeah, we're going to make shortest path or travel assessment problems decision here. Just only click here in the layout. But if we would like to input or yeah, if we would like to add the how to say more precision data, we can also use the load locations features here. But for sure, there are a number of steps to make shapefile data for the points. Here, I just only use the random points here to show you about the shortest path. So here we can look at the detail for graphic one, for example. This is going to be this is going to be our first starting point. And then there are a number of information here. Yeah, source ID is going to be Jalan. This is going to be road. Yeah, and then for this we can set the properties by clicking the road properties over here. So this is going to be very important to start by setting the impedance, for example. Yeah, this is the attribute. Impedance is going to be in the meters or as a length. So this attribute we have to define it or determine it in the network dataset. So previously, actually, the network dataset is going to be very important to you before we go to this step. Then again, this one is going to be the length in meters, and then I will let this information like U-turns and junctions, for example, are allowed or not. We can set it here. Yeah, and then also the output type of drive can and then distance unit we're going to be it's going to be meters, and then attributes going to be hours here, and then click OK, and then we're going to show again. We can see this is going to be the root results for the traveling assessment problem. If we look at this one, based on the how to say the graphic sequence here, number 1, 2, 3. So they're going to be some routes for visiting the the destinations here. So this is the shortest path, and then we can look at actually here for the routes for the travel for the salesman. They will or he will use. I mean the total length that will be used by the by the salesman is going to be 39 kilometers. So if this is in meter here, so it means 39 kilometers. Yeah, this is the result for the shortest path or the new routes. And then, for example, the service area will show you here. For the surface areas, we are going to need the facilities and then polygons lines. Actually, like facilities here, I will use the random points. Okay, for example, for facilities, I will use this one. This is going to be our facilities, and then we're going to find out the surface areas of each facilities. It's going to be like a buffer area, if you know about buffer area. The buffer area is going to be like a little distance from the epicenter, but here, this area, it's going to be about the surface area will consider the length of the road network when managing impedance. Okay, so here, for example, there are 5 areas, and then we can click the properties here, surface area properties, and then we have to set, or we have to enter the noise setting is correct. For example, in the impedance, for example, impedance length, yeah, in the meters, and the full breaks is going to be 1000, means 1 kilometer here, and then we click OK, and then we solve. So this is the area, 1 kilometer, yeah, surface area for each facilities. And then if we change the default breaks, for example, to be 5 kilometers or 5,000 meters, it's going to be like this. This is going to be solving properties. Oh, yeah, this is going to be 5 kilometers. Okay, so there are different areas here, quite wide areas. Yeah, so this is the surface area. If we use like a buffer area, if we use buffer, they might only show us the linear distance from the epicenter, but if we use the surface area, they will consider the length of the roads. Okay, so this is the surface area. For example, if we have the customers over here, and then we are going to set the distance for the customers to visit our store. For example, we can set it by using the surface area. And then I will focus on the vehicle routing problem. I will click the vehicle routing problem here. So if we look at the vehicle routing problems features here, there are a number of, for example, parameters that we have to define. Okay, so we'll use this. For example, like orders. Orders means the demand. Okay, and then depot, and then also the routes. Routes is going to be the vehicles that we have or that we are going to assign. And then there are a number of sets. For example, like route renewals. If we set the route renewals, it means we will allow the multi-trip delivery for each vehicles as long as the time is still allowable. Yeah, and then also specialties order pairs, for example. Yeah, here I'm going to add, for example, I will use the Excel data here, and then I will make demand point, for example. Actually, I can use the longitude and latitude data by using the Excel, Excel format, and then I will I'm convert it to the shapefile data. But since our time is limited, so I will not explain. I will explain later. If you have any question for that, I will explain it more. And yeah, maybe we can discuss more about the data here. But here, in this case, I will try to make, for example, demand point 1, demand point 2, and then demand point 3, demand point 4. Okay. And then here, for example, they have their own demand in tons. For example, I will make it like this one's going to be 10 tons, and then 6 tons, and 8 and 3 tons. Here, for example, the demand point is going to be like this. This is our demand point. We have 5 demand points. I'm sorry, 4 demand points here, and then they have their own demand tons. And then for solving the vehicle root problems, we need to specify the capacity of the vehicles. For example, this is the demand, and then this is the vehicles. Vehicle. Okay, and then capacity in ton here. For example, we have 3 vehicles, or maybe 2 vehicles, vehicle 1 and vehicle 2 with heterogeneous capacity. Here, for example, the capacity is going to be 4 tons, and then this is going to be 6 tons. Okay. So before we continue to specify the demand, specify number of sets here, for example, like delivery quantities here. So before we specify that, we have to compare or fit the demand to the vehicle capacity. Yeah, so these are the 2 types of vehicles, and two vehicles with their own capacities in tons. So we have to define the maximum capacity here. We have to define the maximum capacity. We know that vehicle 2 has the biggest capacity, 6 ton here. And look at the demand. We have to define, or we have to divide the demand based on the capacity. If in the method, we can directly use the demand as this number, but in the GIS we have to divide the demand based on the vehicle capacity. So how do we divide the demand? For example, like demand point 1. Here, demand point 1, we have 10 tons. But yeah, we have the capacity of the vehicles. Okay, we just only have 6 capacities. Means the capacity is less than demand, so we have to make dummy request for demand point 1. So we'll make it as demand point 1 A and then demand point 1 B here. So 10, it's going to be like we have to divide it, yeah, to, for example, this one is going to be 6 tons for full capacity with the biggest vehicle capacity, and then the rest is going to be same before here. And then, for example, the next one is we have only we have, and then demand analysis, use it as one demand of here, and then next, so it means we have to do it to be demand B A and demand point B. It's going to be like 8 minus 6. Have full rest to be combined the phosphor did separately. Then demand point 4 is to be, so it is less than 6, so just only 3 here. Demands and demand. This one in, so this is going to be graphic 1. It's going to be so here this actually there are the same points that request 10 tons that we want to and tons, so one dummy. So here right point, and then service, for example, like uploading time here, for example, 0.50 0.015. Hello, hello. Could you hear my voice?
Yes, Pak Inca.
Okay. Okay. So we'll continue explaining this. So here, for example, we have demand point 1. So the delivery quantity is going to be 6, means it's going to be 6 ton here, and then the service time is going to be 0.15 in hours. Yeah, so it means like 0.15 hours, and then if we set the time in, for example, started from 7 a.m. to 4 a.m. 4 p.m. Okay, and this is actually there are a number of sets that we can determine, but here I will leave it default. So service time, I just only set the service time window start and end, and also the delivery quantities. It means we have to send 6 tons to demand point, and then click OK. And then we have the demand from the same location. We can copy it to this one. So we can set it as demand point B with the rest of the demand 4 tons here. So we have already set it here, and then click OK. So we have demand point 1A, and then demand point 1B. And then the next one is about demand point 2. We have just only 6. So we'll rename this to demand point 2, and then the service time, for example, 15 hours, and then started from 7 a.m. to 4 p.m. for example. And then the delivery quantities must be 6, since we only have 6 here, demand point 2. And then click OK. And then the next one is demand point 3. Demand point 3, demand point 3A, and then the service time, we set it the same for every demand points. Also the time windows, for example, 8 a.m. 7 a.m. to 2 p.m. for example. So it may be different between each point or each demand points. And then the delivery quantity will be 6 here. 6 and 2. I will copy and paste it here. B. And then yeah, the same. Oh, sorry. B is going to be 2. Here, the rest of the demand. And then demand point 4. Demand point 4. Oh, the service time we can specify it here. Time window start. For example, 8 a.m. to 4 p.m. And then here 3 delivery quantity. So based on the set of specifications based on the orders and also the depots, we can specify in, and then it will determine the variant of the VRP. For example, like if we set up the delivery quantities and also the pickup quantities, it's going to be determined as the VRP with simultaneous pickup and delivery, for example. Yeah, in this case, we just only use the delivery quantities, and then the depot here. Here I will just select, or I will just choose the random point by using this icon, and then here. So this is going to be my depot. Okay, for example, the depot will be open at 6:30 a.m. and then will be end around 5 p.m. for example. Okay, and then this is the depot and the route. So remember, we have 2 vehicles here. So the route means vehicles. I will add item here, right click and then add item, and then this one is vehicle 1, and we have to set or to determine the start depot name. This is going to be depot, and then, for example, in this case, we have to specify that the vehicle is going to go back to the depot after finishing the delivery. So go back to the depot here, and then yeah, this one's depot service time to be like the loading time. I will set it, for example, like 0.5 hours. So that means 30 minutes here. And then end depot service time, no. I will set it no. Earliest maybe like 7 a.m. Okay, and then the capacities, I will set it here. Capacity 4 tons. And then there are a number of sets, for example, like fixed cost, or yeah, fixed cost, and then cost per unit time. Yeah, we can specify it here, and then cost per unit distance. This one's variable distance, this one based on time. And then, for example, like distance going to be like fuel cost, for example, or even the carbon emission cost. You can set it as cost per unit distance, and also per unit time, for example, driver's salary, and then the overtime start time, and then cost per unit overtime. You can specify it here. And then this one is going to be maximum order count. This is going to be the maximum allowable trips that a vehicle can do. Okay, as long as the time is allowed or possible to for the driver or for the vehicles to deliver the demands or goods. So this is maximum order counts, and then we can also specify if we have to specify the maximum total, for example. So the vehicle will not be allowed to travel more than X distance or X kilometers, for example. We can specify it here, or even the total time or travel time. We can specify it here. But we don't, or we do not want, or we are not specifying it, or we are not considering this constraints. So we just only set capacities here in this case, and then start depot service time, and then start and end depot name. So we'll just leave it null here. We will not set like the cost here. So if we do not specify the cost, so it means the objective function of the optimization is going to be minimizing the distance only. Okay, so then I will click OK, and then here I will copy and paste vehicle 1 and vehicle 2 here, and then the start depot name and end depot name is going to be the same. Capacity we set it 6 for vehicle. So here we will just only need to specify it based on the menu provided GIS, so it's going to be easier for us. And then this one is the routes and the route renewals. I think if we would like to specify the multi-triples each vehicle or for each vehicle, so we need to specify the route renewals by right click here and then add item, and this is the depot name. We have to specify the route name, for example, vehicle 1 service time. Yeah, if they go, for example, from the depot to the main point one and then go back to the depot for the next trip, they will need to load the goods again or the materials again. So I'll set it, for example, like here 4.5 hours, so it means 30 minutes here. And then I will add again for the next vehicle, same depot, and then route name is vehicle 2. Service time is going to be 0.5. Click OK here. And for example, there are barriers in this case. For example, like disaster areas or the road barriers that may not be passed or impassable here. I can use the polygon barriers, for example, here. This area, for example, we will not allow the vehicle to use this area. And then if we look at the presentation over here, the red lines here, actually we can also add the lines, the points based on the load locations. So we can specify the impassable roads, for example, in the relief routing decisions in the first stage. We make it as the shapefile or the vector data, and then we load it. We can use the data to be the barriers case or in our problems. Okay, and then this is the barriers, and I will solve this. Okay, moment. I will have to set the vehicle routing problem analysis or properties. Here, this is important. So when before we solve the vehicle routing problems, we have to set or to make sure the analysis setting of the vehicle routing problem properties here based on the attribute. So here, time attribute, for example, I will set it as time in hours, and then distance attribute will be length in meters. And then this is going to be the date here, and then capacity count. Okay, I will leave it 1 here, and then time field units, I will use hours, and then distance field units, I will use it meters here to make it meters, look at the attribute. And then this one's U-turns, load or not, we can set it here. And then distance unit and time attributes here, same, hours and meters. This one also, hours and meters. Then I will click OK, and I will try to solve it. So this is the route decision. We can see from the route, there is I mean, like if we set the barriers for example, the polygons barriers here, so the vehicle will avoid to use the polygons. And then, for example, if I delete this one, and then I will try to solve it again. Oh, I think the polygon here, for example, I'll make it here, polygon and solve it. So yeah, they will avoid the barriers area. Yeah, for example, like line barriers here. I use this one, and then they will try to search for another another lines to save areas. So here again, this is I think the significance of the GIS space optimization. So we can see for solving less than 1 second, if I'm not mistaken here. So it's easier since we just only specify. It's easier for us to specify the features required in the GIS. And then also, if we look at the results here, we can see there is only vehicle 2 used for the assignment. Even though even we specify 2 vehicles here, there was vehicle 1 and vehicle 2, but the GIS only determine the most needed vehicles. So they will not assign the vehicle 1, for example, if the vehicle 1 is not needed or is not required, just only required vehicles. So it's only for vehicle 2. How to read the result? You can see here the depot visits, I think. So here in the depot visits, we can see the vehicle will start from the depot. This is the sequence 1 from the depot, and then we can see the loaded quantities. They will deliver 5 tons to the next sequence. This is going to be 2. Next sequence to demand point 3, and then they will deliver 2 from 5. They will deliver 2. This is the results for the cumulative distance. So from the depot, they will go to 3 with the distance 2 kilometers here. You can see, and also travel time. You can also see here. And then you can see the time, starting time, for example, arrive time 7:45, and then depart 7:55 54. This is the result of the optimization. You can make it as a summary and as a table. But here from 5 again, they just only deliver 2 to demand 3, and then from demand point 3, they will go from sequence 2, they will go to sequence 3 to deliver to the demand point 4 with 3 tons quantity. So full load, 5 tons will be delivered to demand point 3 and demand point 4. 2 to demand 3 and 3 demand point 4. If you can see here, 1, 2, 3, and then this is 5. So it means if there is no sequence 4, we can see in the depot visits. So it means after visiting the demand point 3, they will go back to the vehicle, will go back to the depot here to make another trip. So here we allow the multi-trips. So it means the vehicle is allowed to make another trip. So this going to be started from the depot again, and then 5 is going to be demand point 1. You can see the depot. The vehicle will load 4 tons and then go to demand point 1 to deliver 4. So it means there is no more loads on the vehicles, and then after 5 we'll go back to depot again, and then 6 load 6 to 7 full load, I think, yeah, for 6, and then go back again to depot, and then to demand point 2, and then 10 we'll go back to depot, and then 11 demand point 1 to deliver 6, and then go back to depot. So this is going to be the, if we look at this vehicle, this is going to be the result. Assigned vehicle, for example. Okay, and here there's only vehicle 2. And then this is going to be the routes. So for example, I will make a depot, and then depot demand point 3, and then for demand point 4, then go back to depot. Here, this is the first route. Since this is 3, and then go back to depot. 4, 5, 6. So it means just only one route. Depot demand point 1, and then depot. Yeah. And then same depot, demand point 3 and depot. Two, depot, and then demand point 2, go back to depot, and then demand point 1 again. Okay, so this is the final assignment for the vehicles with, for example, loaded quantity in tons. Loaded quantity for the first is going to be 5 tons, and then this one is going to be 4 tons. The next one, 6. Then this one 6. And this one is 6. And this is 0. This must be 0 because this is the final and then we can also report the, I'll say, the total distance, for example, in kilometers, then total time in hours. Yeah, here we can see the recapitulation of the distance traveled. Here 1, 2, 2, 3, and then 4. Previous distance. This is going to be 3.8 kilometers. We can look at distance traveled here. And then cumulative travel time only 0.25 hours here. And then this is going to be the cumulative distance. I think this is the cumulative distance, 10 kilometers. Total distance going to be 10 kilometers, 10.1 kilometers. Here we can make, based on the GIS-based optimization, we can make decisions about the routing problems, especially in the relief routing decisions. We can also add barriers here, and also, for example, like demand priority. Yeah, we can also set it by, for example, using the revenue here. Revenue, actually for the commercial logistics, we can set it as the revenue for visiting the demand point. But in case of routing decisions, we can the revenue as the priority of the demand. It's going to be like the weight of each demand points. For example, in the case of the eruption of the eruption, so must be some areas that are needed to be evacuated sooner. So we can set it as a priority demand here. So there are many or a number of variants of ERP that we can model in this software. Okay, I think this can show you or can explain the GIS based optimization, how based optimization, the utilization of the GIS optimization, especially for determining the short path and also the routing decisions. So I think that's all for me. If there is any questions.
Okay. Thank you very much, Mr. Inca. Let's give big applause to Mr. Inca, everyone. I don't know if my connection is so bad or can everyone hear me?
Hello.
Hello.
Yep.
Okay. Okay. So I think if you have any question, everyone, you can raise your hand and I will give you opportunity to ask question. But before that, maybe let's stop the recording because normally